Hello. Okay, I'm gonna do this problem set, and you know, just like last time, it's gonna be the exact same thing. So I don't. Okay, whatever. Let's see. My name is Adrian. Okay. Uh, okay. Let's see. Graph the following exponential functions. Make sure to identify the domain and range. Sure. Okay. I could probably do this. So let's see. If I'm just thinking about like what our normal like something to the x power, like e to the x or something, I know they all kind of look something like this. At least when this number is bigger than 1. They all kind of look something like this. Um, but so let's get to it. Hmm. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3. All right. The way I like to do these is probably just by plugging in points. Uh, okay, the easiest point to plug in is 0, because I know anything to the 0th power is going to be equal to 1. So 0, 1 should always be on our graph. Uh, yeah, okay. And now let's plug in some other points. So let's find f of 1, f of 2, f of 3, and let's find f of -1 as well. I think this should give us enough points. So we'll start with 1. F of 1 is the same as 2 to the 1, which is 2, which means that the point 1 comma 2 is on our line, or is on our function, is on our graph. Let's see, f of 2 is 2 to the 2, which equals 4. So we know that 2 comma 4 is on our graph. F of 3 is the same as 2 to the 3, which equals 2 times 2 times 2, which is 8, which means that 3 comma 8 is on our graph. All right, f of -1, 2 to the -1, just the same as 1 over 2 to the 1, so 1/2, which means that -1 comma 1/2 is on our graph. Okay, let's start plotting these. So -1, 1/2 is right there. 1 comma 2 is there. 2 comma 1, 2, 3, 4. Then 3, 1, 2, I think that looks right. Okay, and I know as we keep going this way, our numbers are going to get bigger. And as we keep going this way, our numbers are going to get smaller. So let's just plot that out. Shaboom. What is that line? Okay, that looks good. So let's think about our domain and range now. Our domain is all of the x values will hit. And so I know Miss Hardy in class thought about like if we like smoosh this line down, what x values are we hitting? And so if we think about that, this is going off this way forever. It's also going off this way forever. So we're going to get all of the x values. So we're going to get all of them from -infinity up to infinity. Now our range, this is a different question. Now we're thinking, what y values can we hit? Good question. What y values can we hit? Well, let's see. We can always put in a super big number here, which means that we can always get bigger and bigger numbers. So I know we can at least go to infinity, positive infinity. But how far down can we go? Well, let's think about it. If we put in a small number here, like -1, -1 is pretty small, then we get 1/2. If we put in -2, then we get 2 to the -2, which is 1 over 2 squared, which is 1/4. So 1/4. If we put in -3, we're going to get 1/8. -4, we're going to get 1/16. -5, we get 1/32. As you can see, these are getting smaller, but they're never going to be 0 or less than 0 even. So I'm going to say from 0 to infinity. Okay, awesome possum. Let's move on. All right. Okay, we got a graph now. 1, 2, 5, 6, 7, 8, okay, so remember up here when I said this is kind of what all the graphs look like? Well, that was because we had something greater than 1. Now we have something less than 1 as what we're raising to a power. So things are going to be different now. How different? Not so different. In fact, we have a really easy point still, because if we put in 0 here for x, we're still going to get 1. So 0, 1 is still one of our points. Awesome sauce. Okay, let's now plug in a few more points. So let's try g of -1, g of -2, g of 1, and g of 2. I think this should give us enough points. So g of -1 is the same as 1/2 to the -1 power, which is the same as 2 to the 1 power, which is 2. Which means that -1, 2 is on our line. And now let's see, g of -2 is the same as 1/2 to the -2 power, which is the same as 2 to the 2 power. And I'm getting this 1/2 to the -2 equals 2 to the 2 because when we have like 2 to the -2, we flip it. So we flip it into 1/2. And now we're taking this 1/2 and we're flipping it, since it's to the negative power, into a 2. Okay, 2 squared is 4. So -2, 4 is on our line. And this should look pretty familiar, except a little reversed. On our original function, we had 1, 2, and now we have -1, 2. We had 2, 4, and then we have -2, 4. So without even doing any math, if we wanted to find g of -3, it would seem to be related to this right here. So g of -3 should be -3, 8. And if we do our math to find out, let's see, 1/2 to the third to the -3 equals 2 to the third, which equals 8. So -3, 8 is a point on our line. Awesome. Okay, g of 1. Oh my gosh, I'm dying. Okay. Should be okay. Hopefully. Hopefully. It might not be okay. Okay, let's see. 1/2 to the 1 is 1/2. So we have 1, 1/2 on our line. G of 2, 1/2 to the 2, which equals 1/2 times 1/2, which equals 1/4. So we have 1, 1/4. And again, we can compare this to our first function. -1, 1/2 is now 1, 1/2. 1, 2 is, I never did f of -2, so ignore me. All right, well, let's graph. So we have -1, 2, -2, 4, 3, 4, and then -3, like 8. I don't know, that seems right. 1, 1/2, 2, 1/4, 1/8, and then we get really small. So now we go, boom. Okay, awesome. Now, our domain and range. Our domain looks the exact same to me because we can, again, smoosh everything down to the x-axis. So our domain from -infinity to infinity. Awesome. Now what about our range? our range looks like we're in the same situation here. Um, we still aren't going to be able to go below 0, but we can always go bigger and bigger and bigger. And although we can go always smaller and smaller and smaller, we can never go smaller than 0. So 0 to infinity. All right. Solve the following equations involving exponential functions. Okay, I'll try. So let's see. How should we do this? Okay, I'm gonna, looking at 4 and 2, or 4 and 8, I know, I have a sneaking suspicion that they are both powers of 2. What does that mean? That means I can write them both as 2 to the something. So 2 to the what equals 4? That's 2 squared. So I just rewrote 4 as 2 squared. And then 8 is 2 cubed. Okay. When we have an exponent to an exponent, we multiply them. So I'm going to write this as 2 to the 2x equals 2 cubed. And since we have the same base, we could take the log base 2 of both sides to get 2x equals 3. Divide by 2. That means x equals 3 halves. Wonderful. All right. I think we could do a similar thing here with 9 to the x minus 1 power equals 1/3. Except now, rather than powers of 2, what do you think these are going to be? I'll give you a moment to think. Okay, I don't want to spoil it, but you're running out of time. Hurry up. Okay. Okay, I'm just going to tell you. Powers of 3. Okay. I hope you got it. I hope you got it before me. Okay. But if you didn't, that's okay. You know, you don't have to be fast at math to be good at math, you know? There's, yeah, probably. Well, you know, all of the cool people in math were also like really fast at it. Um, but you know, you don't have to be cool to be good. Well, but it is good to be cool. Anyways, let's see, 9 we can write as 3 squared. So 3 squared to the x minus 1 power equals 1/3. How are we going to write that as a power of 3? You're right, 3 to the minus 1. All right, now we can distribute. And by distribute, I mean we have an exponent to an exponent, so we're going to multiply. So we get 3, 2 times x is 2x. 2 times minus 1 is minus 2, equals 3 to the minus 1. Just take the log base 3 of both sides, and we get 2x minus 2 equals minus 1. Add 2 to both sides. We get 2x equals 1. Then divide by 2, we get x equals 1/2. Awesome. All right. Let's solve this one a different way. Yeah, sure. Sure, that sounds fun. How should we do this one? Let's take, so we have 2 to 3x equals 16, equals 16. And let's take log base 10 of both sides. So log base 10 of this, log base 10 of this. We get, and now using our log rules, we can take out the 3x. So we get 3x log 2 equals log 16. Divide by log 2 on both sides. Since log 2 is just a number, we get 3x equals log 16 over log 2. Then we can divide by 3 on both sides, and we get x equals log 16 over log 2, 3 log 2. because the dividing by 3 puts the 3 in the denominator. Okay. What if you wanted to figure out what this was? Well, you could plug it into your calculator. And if you plugged it into your calculator, you would get, let me see, 4 thirds. 4 thirds, so 4.333333333, and so on. Awesome. How should we do this one? Do you think we should do the log base 10 of both sides, or maybe put them both as a power of 5? Oops, I spoiled it. They're both powers of 5. Um, let's do it both ways. I'll do both ways at the same time. How about you do one way? You do one way, and then you check your work. Or you could do both ways. And I'll do it both ways now as well. And then you can tell me. I don't know what you would tell me, but actually don't tell me anything. Just do it. One of them. It'll be helpful, probably. Let's see. Log of 1/5 to the 2x equals log 25 log 25 over 2 log 1/5. Okay. Both of these are correct answers. And this is just two different ways to get there. I don't know which one makes more sense to you. To you. To you. Personally, I like this way. I think this makes more sense to me. But you wouldn't be able to use your calculator for it. So if you wanted to use your calculator, you'd have to do this way. So yeah, I don't know. If you're a calc user, then do the second way. Okay, given the following logarithmic equations, solve them by first turning them into exponential functions. Assume log with no number means base 10. Yeah, I've been assuming that. I assumed it here, and here, and elsewhere. I didn't write the base. Okay. ln of 3x equals 2. ln, remember, is the natural log. Okay, which is base e. So in order to undo the ln, I need to raise both sides to the e, or put both sides as the power of e, or whatever. Okay, those cancel. You get 3x equals e squared. That's not a 2. That's a 2. All right, and let's divide by 3 on both sides, and we get x equals e squared over 3. Awesome. That's a good answer. If you wanted to know like a number, technically this is a number, but it's not like if somebody asks you your favorite number, you don't say e squared over 3. You'd probably say like 7.4382, or something like that. So if you wanted a number like 7.4382, you could just put this in your calculator. But I'm not going to put it in my calculator because I don't have a calculator. So, yeah. But you could put it in your calculator. Okay, log 5 of x minus 1 equals 3. We can do this. Put both sides into the power of 5. I need a new way of saying that. I don't know what you call that. Okay, anyways, the 5 and the log 5 cancel. And you get x minus 1 equals 5 to the third. add 1 to both sides, and x equals 5 cubed plus 1. 5 cubed is 125, plus 1 equals 126. So x equals 126. Awesome. Okay, let's use green. Oh, maybe we'll use. Okay, you know what? We'll use green and red for this one because I'm excited for Christmas. Are you excited for Christmas? It's so sad that you don't respond. 4x plus 7 equals 10. All right, subtract 7 from both sides. You get 4x equals 3. And let's divide by 4 to get x equals 3/4. And let's even draw a little Christmas tree. Oh, that's definitely not my best Christmas tree, but it's not bad. Ooh, it needs a star though, don't you think? Okay, that was my worst star, actually. Okay. Anyways, let's continue on doing our thing. 3 to the negative 2. What is 3 to the negative 2? Good idea. I mean, good question. It's 1 over 3 squared. What is 1 over 3 squared? Well, 3 squared is 3 times 3. 3 times 3 is 9, so 1 over 3 squared is 1 over 9. Yippee. Yellow I feel like is a bad color. Pink is fine. Okay. I hope you guys are doing okay with these logarithm exponential kind of things. If not, I do offer help for free. Well, I mean, I don't do it for free. I get paid, but you don't have to be the one to pay me, which is very nice for you guys. So you can always show up and you know, I'm pretty nice, I think. Maybe. 2x plus 1 equals 4 squared. 2x plus 1 equals 16. Subtract 1. Subtract 1. 2x equals 15. Divided by 2 implies that x equals 15 over 2 is 7.5. Okay. Now, we have some expanding to do. I really like this, actually. I like doing this. We get to use all of our log rules. So, let's remember our log rules. So we have ln of x plus ln of y equals ln of xy. We have ln of x minus ln of y equals ln of x over y. Let's see, we have ln of x to the b equals b ln of x. Any more log rules? I don't know, but I'll write them down if we come across them. So do not worry. All right, what log rule should we use here? That's right, the division one. Division one. Oh gosh, I'm really running out of power here. How much more do I? Oh my gosh. Okay, I'm sorry if my explanations are going to get marginally worse from now on, but I gotta go. Let's see. ln of 5x cubed over square root of y. Now think about this. Square root of y is the same thing as y to the 1/2 power. All right, so we're going to use that eventually. Not yet, but eventually. So first step, ln of x over y, so 5x cubed over square root of y, is the same as ln x minus ln y, so we get ln of 5x cubed minus ln of, I'm going to just write it as y to the 1/2. Okay. And now let's see, we can take out this cube into, actually before we take out this cube, I'm going to split up this multiplication here into ln of 5 plus ln of x cubed, put this in brackets, minus ln of, I'm going to take out this 1/2 now, 1/2 ln of y. All right, and now we can take out this, so ln of 5 plus 3 ln of x minus 1/2 ln of y. Okay, I hope you followed these steps here between these two places. So first, I split this up into addition because make a split multiplication into addition. And then here I brought out the power into the front. And here I also did that. Okay. So let's see. Log 2 of, this is all multiplication, so I'm going to write it out as all addition. Log 2 of x squared plus log 2 of y to the 5th. Log 2 of 8 is 3 because 8 is 2 to the 3rd power. So I'm going to write this out as 3 plus, now I'm going to bring out the exponents. 2 log 2 times x plus 3 log 2 of y. Check. Choose a different color here. Okay. Log 10 over 3x. So we can write this out as subtraction. So log of 10 minus log of 3x. Now, log base 10 of 10 is 1 because 10 to the 1 equals 10. So let's write this out as 1 minus, and now this is multiplication here, so we can split this up as log 3 plus log of x. All right. Oh my gosh, this looks disgusting. This looks horrible. So let's split it up into ln of x plus 1 to the 4th plus ln of x minus 2 to the 1/2. Okay, this is looking better already. All right, we can bring out this 4, and we can bring out this 1/2 to get 4 ln of x plus 1 plus ln of 1/2 ln of x minus 2. And now you may be tempted to split this up even further, but you can't. You can't do it. So don't do it. Okay? Because then you'd be wrong. And not that there's anything with, like wrong with being wrong. It's okay to be wrong sometimes, but it's not something to strive for, definitely. So don't do it. This is good. This is great. This is as far as you need to go. All right, now condense the following logarithms into one logarithm. So it's basically what we just did, except backwards. Okay, coolio. If I did it one way, I could do it the other way, right? That makes sense. I just found a staple. Okay. All right, let's see. So we have log 7 of x plus 4 plus 2 log 7 of x. The first thing I'm going to do is move this exponent back in to get log 7 of x plus 4 plus log 7 of x squared. And now I can combine these into one logarithm, and it's going to be with multiplication. So log 7 of x squared times x plus 4. And I can distribute that, x squared. So we get log 7 of x cubed plus 4x squared. Done. Awesome. All right. I'm going to bring these in now to get log of x squared minus log of square root y. And I got square root of y here because y to the 1/2 is the same thing as square root of y. All right. And let's see. So log x squared minus log root y equals, we can rewrite this as division with x squared over root y. Awesome. Okay. I'm sorry. I apologize because this is poorly written and I wrote it. So I'm sorry. Because of course you should follow PEMDAS, but still, this should definitely have parentheses around something. Anyways, we'll work left to right since that's how you work. That's how you do the equation. You do things left to right when they're all like order of operations and such. Okay, ln x plus ln x minus 3. We're going to combine those using multiplication into ln x times x minus 3 and then minus ln 5. Okay, x times x minus 3 is the same thing as x squared minus 3x. And then minus ln of 5. We can combine these using division. And we get x squared minus 3x over 5. All right. These ones are slightly harder, but you can do it. Thank you. I think I can do it too. Ln, oh, I have to solve them. Okay. Oh, okay. I don't think this is going to be horrible, I think, to do. Well, let's try it. Okay. I'm going to combine these using okay. If you get lost here, I think it's okay. I think it'll be okay. I think you'll be okay. This is going to be kind of difficult. And we're going to get lost in the weeds at some point. But it's okay. It's okay. X squared, let's see, x plus 4 times x minus 1 is x squared minus x plus 4x is minus 3x plus 3x minus 4 equals 3. I'm going to put both sides to the power to e to the power of both sides. And we get the e and the ln cancel. So we get x squared plus 3x minus 4 equals e cubed. We're going to have to use the quadratic formula here. Oh my gosh, 3%. This is getting scary. Minus e cubed on both sides, okay. All right, don't undo anything. Okay, so we have x squared plus 3x minus 4 minus e cubed equals 0. And so let's use the quadratic formula. Okay, if you remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. I didn't sing the song or do the call and response. I'm sorry, but that's just the way it is sometimes. So x equals negative b is 3. So negative b plus or minus square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is, let's see, how should we write c? Negative 4 minus e cubed. Negative 4 minus e cubed all over 2a, which is 2 times 1. All right, and let's see if we can simplify this at all. 9 minus 4, 9 minus 4, 4 times, okay, so plus 16 plus 4e cubed over 2. All right, that's it. That's the answer. I don't know if one of those is extraneous. Actually, definitely one of them is. But that's the answer. If you didn't get that, that's okay, because that was hard. All right, okay, these are just they're not slightly harder. These ones are harder, okay? So don't even be so condescending to say slightly. Idiot. It's okay. I can talk to the maker of this like that because it was me. Oh my gosh, I'm on 2%. Okay. But we only have two problems. 1% per problem. Wait. Yeah, this should be fine. Okay. I'm gonna put the 3 into the exponent to get log base 2 of x cubed minus 1 equals log 2 of 5x minus 4. Okay, this is horrible. Okay, notice this, that log base 2 of 2 equals 1. So I'm going to rewrite this 1 as log 2 of 2 to get log 2 of x cubed minus log 2 of 2 equals log 2 of 5x minus 4. And then I'm going to combine these into one thing using our division rule. So x cubed over 2 equals log 2 times 5x minus 4. I'm going to raise both sides to the power of 2 to cancel these, and we get x cubed, oh fudge, over 2 equals 5x minus 4. Multiply by 2 on both sides to get x cubed equals 10x minus 8. And so we get x cubed minus 10x plus 8 equals 0. How do you solve this? Um, I don't know. We could um uh okay, if you got this far, that's wonderful. That's brilliant. That's very good. If you wanted to go farther than this, there is a formula like the quadratic formula, but for things with rather than x squared, x cubed. So if you wanted to solve this out, just look up the cubic formula and plug in your numbers into there, and it'll give you the right numbers. But this is as far as I'm going for now. Okay, 7 to the 3x plus 2 equals 4 to the 4e to the x? God, who made these? Okay, let's take log 10 of both sides to get 7, 3x plus 2 equals log 4e to the x. And we'll bring up the exponents to get 3x plus 2 times log of 7 equals x times log of 4e. And so we get, I'm going to divide by log 7 on both sides. I'm going to distribute to get 3 log 7 times x plus 2 log 7 equals x log 4e. All right, I'm going to subtract this on both sides. I'm going to subtract this on both sides to get 3 log 7 times x minus x log 4e equals log 49. I got log 49 here because I brought the 2 inside. Okay, I'm almost out of time, but it's okay. It's okay. Let's see. So we get x times, I'm factoring out an x on this side. I'm factoring out these two x's to get 3 log 7 minus log 4e equals log 49. I'm going to bring this 3 on the inside here to get, and I'm going to combine these using our division rules to get log of 7 cubed over 4e equals log 49. I'm going to divide by log of 7 cubed over 4e on both sides to get x equals log 49 over log 7 cubed over 4e. Done and dusted. Awesome sauce. I hope you made it this far. Actually, I hope you made it this far. If you didn't solve any of these, that's okay, because these were so much more difficult to solve than I initially thought they would be. Okay, uh, awesome. Good luck on your problem set. Come see me if you need help. Bye bye.